Hi everyone, today we're going to show you the revolutionary Tuki protocol at play. So let's start from a contractor view. This is an actual campaign with tokenized real estate. Most campaigns in terms of look and feel will look more or less the same, different maybe incentive models, different things being requested as a conversion. In this case, this is a campaign selling tokens. One of the nice things having this run on a blockchain is basically we have full transparency that can be verified, and also thanks to the Tuki protocol we have permissioned views. So if you're the contractor, you're going to see all of these participants, including ones that have yet to be verified, and then you can actually go and verify everything and then approve their conversions. And if you're just a regular participant, you're going to see only the completed conversions. And of course there's also like certain privacy parameters where the converters may choose if they want to be exposed on the public list or not. Now for the Tuki protocol, to see a bit how it works. So this is the referral graph for this campaign. It's quite a large referral graph. If we try to zoom out here, you can zoom out quite a bit. And this is a large referral graph, and of course it starts by only showing the first three layers. Then if you see a pulsating node, that means you can press on it and see what that user did onwards, who it referred onwards. Now if we go and look into a specific subgraph, so let's look at it more in depth. So again, whenever you have a pulsating node, you can click on it and see what that node did next. You have here a legend where you can understand which type of user each of these nodes is. Now let's look at a specific subgraph within this very big influence graph. So we have this user L4 who got the link directly from the contractor, and then this user forwarded to these many people. These are people that actually opened his link, and this is one of the users that from the color we can see he converted and the amount, and then referred onwards to one extra person. Now let's say this thing in play. If we go to the user L4, so L4 has this in his homepage. You can see in his participation, because he also bought these tokens, you can see this campaign. Now if L4 goes into the campaign, so as we said before, you're going to be able to see, let's just refresh it for the profile picture to load. So as we see, a user in this campaign who's not the contractor can only see a very smaller list of only the valid participants. And if any of these users opt to be anonymous, then only their, basically none of their identifying information will be displayed here. Now, in my referrals of this user, he will see only his subgraph. So this user basically sees the subgraph from himself onwards. So let's center the subgraph. So if you recall, this is the subgraph for this user. I'm as the contractor seeing everything. This user only sees from himself onwards. Now, in terms of the, this is a manual incentive model. So when this user got, he got this link directly from the contractor, so he got the maximum referral reward. This is a manual incentive model, meaning that he got to choose how much he wants to keep and how much he wants to pay forward. And then he kept 6 and paid forward 9. So for example, if we try and look at the users that came after him, for example L6 should be, and let's go to L6 and see how he sees the campaign. So again, he will be seeing it more or less the same, just with my referrals. His referrals, he's probably not referred yet, so he doesn't see anything. As we see from him, he's the last one, and he hasn't done his referral yet. And he can still choose. So he can still generate his link, but his maximum is only 9%. So if the L4 user had a maximum of 15%, the multi-party state chain basically relayed the state that mutated the contract, in which L6 only has a maximum of 9, and then he can choose how much he wants to take and how much he wants to pay forward, leaving incentive for others to continue and share it. And then when he generates his link, he will be able to, well, pay it forward and get compensated as a regular part of the contract. Now, let's go back to L4. So L4 has a link, and we're now going to show you live how it works in forwarding this link. So let's remember the state. There are 3 identified users and 4 viewers, 4 browsers that open this link. The beautiful thing about the protocol is it's all happening off-chain, but in a decentralized manner between browsers. So we're now going to show you how a browser opens a Tuki link and automatically becomes part of an off-chain decentralized network, so to speak, a shard per contract that runs a smart contract in a decentralized way, just using these browsers as decentralized nodes. So if we take L4's link, okay, and remember here there's like 4 unidentified and 3 identified. And let's open this in a new browser. So this Tuki link, what you're seeing is basically masking for IPFS. So behind this is basically a routing that ensures that this browser will load the exact hash of a JavaScript code that will enable it to become a node in this decentralized browser network which runs the smart contract. And this is what we call the state hash. This hash allows the browsers to identify itself into a specific state in the state graph of the smart contract. So these combinations of these 2 hashes, they allow the browser to first of all fall into the context of the campaign. So without having this hash, you cannot be even exposed to the information inside this campaign. And once you're exposed to the information, the browser automatically, and this is a user that hasn't signed up yet, hasn't done anything, but this browser has already created an address for itself and marked itself into this campaign. So let's go look in L4. If we now refresh, we're going to see 5. So 1, 2, 3, 4, 5. So this is the new guy. Okay. So we're now July 11th, 9:49. And you see it here, July 11th, 9:49 a.m. So this is the new occurrence. Now what you've seen here is basically groundbreaking and revolutionary in the way that we have now a browser that is fully identified as a peer, a participant in a smart contract, and this did not involve the usage of any servers. So there's no Ethereum servers or nodes involved, no Plasma nodes involved, and no API servers involved. Now, if we go and try to complete these transactions, the reason that it's important to mark the browser inside the campaign as soon as the information is visible is because this already entails an economic offer. Okay, so if this user wants to pay it forward, and again, this is a user that hasn't even logged in or signed up yet, and still the browser is already identified into the smart contract. So now if I try to log in, I'm going to use a login just to save time, but this is a user that is only logged in, doesn't have an address or a public address or a wallet yet. We have a lot of humanity checks in place to make sure this is a human network. So basically this is a regular Web 2.0 sign in, sign up experience. Now, and this user, since this user came also directly after L4, so it's the same like L6, you will only see the maximum of 9. But again, what you're seeing here is basically, so this is a stateful transaction that he received from L4. This transaction was sent purely off-chain in a decentralized manner, no servers of any kind were involved. Now, when he will try to create his link, and he can choose how much to pay forward. So this generation of a link is again a stateful transaction. It's a state mutating transaction in the smart contract, and it's all happening without the involvement of any servers. So this is pure cryptography at play, allowing this browser to participate in a decentralized manner in a smart contract, only using the browser as a node. And basically this user didn't even open a wallet yet. It doesn't have a public wallet, doesn't have his own non-custodial wallet. He doesn't need that. He acts with an address automatically generated for the browser, and it's safeguarded in many ways we can discuss later. And basically participating here and getting the link, what you now saw is basically a stateful transaction, a state mutating transaction in the smart contract that happens with zero server involvement. So no Ethereum nodes, no Plasma nodes, no servers of any kind were involved in mutating the state of the smart contract in this multi-party state chain. In this regards, this is a truly groundbreaking, first of its kind type of transaction, type of network. And now to complete it, basically once I have my referral, I can see my referral graph right now. This is just me. I haven't even registered, so in terms of the public chain, the layer 1, so I'm still identifying with my Plasma address. Now if I pass this new link forward, so this is already a new link, forwarding the new state, including this new fellow, that again made all of this possible without any kind of onboarding. So this user doesn't have a wallet, doesn't have Ether, doesn't have anything, and still he's participating in a smart contract. And basically when he sends his link onwards to a new person, then his referral chain starts updating, and of course all of the referral chains upstream are also starting to get updated. So this is a real, well, this will update everything. I hope it will keep us in scope. Yeah, so here it is. So this is a way, this is already L10, and which is the new user. So what we've demonstrated today is basically the Tuki protocol acting to replace servers with cryptography. You've seen browsers join into a multi-party state network, completely off-chain, completely decentralized, no servers involved. That's a true beauty. We have many other parts of the app, but we'll talk about them in future videos. Hope you enjoyed, and hope to see you on the platform.